the third visitor from beyond our solar system. So here's the deal with this thing called 3I Atlas, and trust me, it's way more fascinating than you might think. On July 1st, 2025, astronomers at the Atlas telescope in Rio Hurtado, Chile, spotted something moving through space that absolutely shouldn't have been there, at least not based on where it came from. This wasn't just another rock orbiting our sun. This visitor arrived from somewhere between the stars, making it only the third confirmed interstellar object we've ever detected passing through our cosmic neighborhood. The first two were Oumuamua back in October 2017, and 2I Borisov in August 2019. And if you thought those caused a stir in the scientific community, well, buckle up, because 3I Atlas is turning out to be even stranger. When they first picked it up, 3I Atlas was already screaming through space at about 137,000 miles per hour. To put that in perspective, that's roughly 61 kilometers per second, which is absolutely bonkers fast. It was sitting about 410 million miles from the sun, within Jupiter's orbit. And here's where things get interesting. The trajectory they calculated showed this thing was moving on what scientists call a hyperbolic path. What does that mean? Well, unlike comets or asteroids that orbit the sun in closed elliptical paths, this object is on a one-way trip. It came from interstellar space. It's passing through our solar system right now, and it's never coming back. It's basically the cosmic equivalent of a road trip with no return ticket. The object came from the general direction of Sagittarius, which just happens to be where the central region of our Milky Way galaxy is located. Now astronomers don't know exactly how big this thing is, but based on observations from the Hubble Space Telescope as of August 20th, 2025, they've narrowed it down to somewhere between 1,444 feet and 3.5 miles in diameter. That's a pretty huge range, but it gives you an idea of what we're dealing with. We're talking about something that could be anywhere from the size of a few football fields to roughly the size of Manhattan. Before we dive deeper into the really weird stuff about this cosmic visitor, if you're enjoying this breakdown of one of the most mysterious objects currently in our solar system, do me a solid and hit that subscribe button. What Neil deGrasse Tyson and other scientists are saying. Here's where things start getting really interesting, and this is where you need to understand that the scientific community is basically having a massive debate right now. On one side, you've got the cautious, methodical approach championed by folks like Neil deGrasse Tyson. If you've been following space news at all, you know Tyson is not one to jump to wild conclusions. In his discussions about 3I Atlas and its predecessor Oumuamua, Tyson has coined the term alien of the gaps, which is kind of like the old God of the Gaps argument, where people used to blame everything they didn't understand on divine intervention. Now we're doing the same thing with extraterrestrials. Tyson pointed out that for decades, astronomers have expected interstellar objects to pass through our solar system. Stars form with tons of extra material, and some of that material inevitably gets ejected into interstellar space. Our own solar system probably sent debris flying out into the galaxy billions of years ago. So finding these interstellar visitors isn't surprising at all. What's surprising is how weird they're acting once we actually spot them. Tyson's take on 3I Atlas. He admits aliens could be an explanation, but as he put it, it's not my first thought. I promise you it will be my last thought, but it's in the list. His approach emphasizes gathering more data, conducting peer review, and resisting the urge to jump to sensational conclusions. Charles Liu, the astrophysicist from the American Museum of Natural History, who co-wrote One Universe at Home in the Cosmos with Neil deGrasse Tyson, brings another perspective to interstellar objects. Liu specializes in colliding galaxies and the star formation history of the universe. And through his podcast, The LI Universe, he's discussed how objects like 3I Atlas can reveal incredible things about planetary formation around other stars. The material these objects carry formed in completely different stellar environments, possibly billions of years ago in some distant star system. By studying their composition and behavior, we're essentially getting a sample of alien real estate delivered right to our doorstep without having to travel light years to collect it ourselves. The Avi Loeb factor and the alien technology controversy. Now, let's talk about the elephant in the room, or should I say the interstellar visitor in the solar system. Harvard astrophysicist Avi Loeb has become somewhat famous, or infamous depending on who you ask, for his willingness to consider that some of these interstellar objects might not be natural at all. Loeb is the head of the Galileo project at Harvard's Center for Astrophysics, and he's been studying 3I Atlas intensively. He's published 11 scientific papers about this object in recent months, which is actually pretty remarkable considering it was only discovered in July. Here's where Loeb's argument gets really interesting, and I'm going to give you the facts as he's presented them. Loeb has compiled a list of 9 to 10 anomalies about 3I Atlas that don't quite fit the profile of a normal comet first. The object's retrograde trajectory is aligned to within 5 degrees of the ecliptic plane where all our planets orbit. The probability of that happening by random chance? About 0.2%. Second, during July and August, the thing displayed what's called a sunward jet or anti-tail. Most comets have tails that point away from the sun because solar radiation and solar wind push gas and dust outward. This thing had a jet pointing toward the sun, and according to Loeb's analysis, it wasn't just an optical illusion from viewing angle. Third, and this is a big one, based on earlier observations through September, scientists calculated that 3I Atlas must have a mass greater than 33 billion tons, making its diameter larger than 5 kilometers. This makes it about 1,000,000 times more massive than Oumuamua, and roughly 1,000 times more massive than 2I Borisov. But here's the kicker. It's moving faster than both of them. Based on the limited reservoir of heavy elements in our galaxy, and the statistics of how often we should see these objects, we should have discovered something like 100,000 smaller interstellar objects before finding one this massive. But we only found 2 before this one. The statistical probability of that sequence? Less than 0.1%, according to Loeb's calculations. And here's where we get into the really controversial stuff that has the astronomy community absolutely buzzing right now. Stick around because I'm about to explain the non-gravitational acceleration mystery, and why some scientists think this might be more than just a chunk of space ice. The non-gravitational acceleration mystery. Around late October 2025, when 3I Atlas reached its closest point to the Sun at approximately 1.4 astronomical units on October 30th, something unexpected happened. NASA's Jet Propulsion Laboratory reported that the object was displaying what's called non-gravitational acceleration, meaning the thing was moving in ways that couldn't be explained by gravity alone. Now, comets do this sometimes through a process called outgassing. When a comet gets close to the Sun, the heat causes ice to turn directly into gas, creating a rocket effect that can push the comet slightly off its predicted path. This is totally normal and expected, but here's where 3I Atlas gets weird. The acceleration measurements from observations at the Atacama Large Millimeter Array indicated that on October 29th, the object was about 4 arcseconds off from where it should have been based on purely gravitational calculations. A.V. Loeb crunched the numbers using momentum conservation. According to his calculations published in his research, for outgassing to cause this level of acceleration, 3I Atlas would need to lose more than 13% of its total mass over the roughly 1-month period around perihelion. That's enormous. For context, if you've got a typical sublimation velocity of around 300 meters per second, losing 13% of your mass should create a spectacular cloud of gas and debris that would be easily visible to our telescopes. The missing tail problem. This is where things get really strange. After 3I Atlas passed its closest point to the Sun, astronomers expected to see this massive debris cloud. They pointed their telescopes at it in early November, and the images released on November 5th from both the Virtual Telescope Project and the R-Naves Observatory showed something puzzling: a compact source of light without any clear cometary tail, no massive gas cloud, no obvious debris field, just a fuzzy ball of light. Compare this to normal comets from our solar system. Comet Lemon from our solar system was photographed on November 3rd by the same R-Naves Observatory that imaged 3I Atlas, and Lemon displays a gorgeous, classic cometary tail pointing away from the Sun, exactly as expected. But 3I Atlas? Nothing like that. It's sitting there looking more like a compact blob than an evaporating ice ball that just lost a significant fraction of its mass. This discrepancy is at the heart of the current scientific debate. Loeb argues that if there's no massive gas cloud, when 3I Atlas reaches its closest approach to Earth in December, and we get our best observations, then the non-gravitational acceleration can't be explained by normal cometary activity. In his Medium articles, he suggested that without evidence of substantial mass loss, the non-gravitational acceleration might be the technological signature of a propulsion system. Before we go further, hit that like button if you're finding this as mind-blowing as I am. The color-changing mystery. Here's another peculiar characteristic of 3I Atlas that adds to its mystique. Recent observations show the object has developed a faint bluish hue, marking what appears to be its third color change since discovery. For a natural comet, this blue coloring is extremely surprising. Dust on a comet's surface should make reflected sunlight appear redder, not bluer. Plus, the surface temperature of 3I Atlas should be roughly 20 times colder than the sun's photosphere, which sits at about 5,800 degrees Kelvin, meaning it should reflect light with a redder spectrum. So why the blue appearance? There are competing explanations. The natural hypothesis suggests it could be a signature of ionized carbon monoxide. When certain molecules get bombarded by intense solar radiation near perihelion, they can emit light in the blue spectrum. The alternative explanation, which Loeb has presented, is that it could indicate a hot internal source or artificial lighting, though he acknowledges the carbon monoxide explanation is also viable for a natural comet. The brightening pattern has also caught scientists' attention. Data from spacecraft including Stereo, SOHO, and GOES 19 during September and October 2025 showed 3I Atlas brightened rapidly, with the intensity scaling inversely with distance from the Sun to the power of -7.5, plus or minus 1. This steep relationship is more dramatic than what's typically observed with conventional comets. China gets there first. Here's where international space politics enters the picture. China's Tianwen-1 Mars orbiter managed to capture and publicly release close-up images of 3I Atlas before NASA did, which created some buzz in the space community. On November 6, 2025, the China National Space Administration released images captured on October 3rd, when their spacecraft was approximately 29 million kilometers from the interstellar object. These images revealed the comet's nucleus and surrounding coma with a diameter reaching several thousand kilometers. NASA had also observed the object with a high-rise camera aboard the Mars Reconnaissance Orbiter, but those high-resolution images hadn't been publicly released at that time. This led to congressional inquiries. Congresswoman Anna Paulina Luna wrote to NASA's acting administrator Sean Duffy on October 31st, requesting the release of observational data related to 3I Atlas. The Pentagon's All-Domain Anomaly Resolution Office, which typically investigates unidentified aerial phenomena, confirmed their following reports about 3I Atlas closely and maintaining partnerships with the scientific community. The Chinese images, while lower in resolution than what NASA's HiRISE can potentially produce, were sufficient to show the basic structure and allowed Chinese researchers to develop animations of the object's trajectory based on a series of 30-second exposures. What makes 3I Atlas different from previous interstellar visitors? Let's compare this to our previous interstellar guests. Oumuamua, discovered by the Pan-STARRS telescope in Hawaii in October 2017, had its own peculiarities. It possessed an elongated shape based on variations in reflected light, and displayed non-gravitational acceleration, despite showing no visible cometary coma or tail. It was relatively small, probably a few hundred meters in its longest dimension, and tumbled through space with a rotation period of about 7 to 8 hours. 2I/Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov, was much more conventional. It looked like a comet, behaved like a comet, and sported a visible coma and tail. It was clearly an icy body outgassing as it approached the Sun, exactly matching expectations. The significant aspect of Borisov was simply that it confirmed interstellar objects could be garden-variety comets, not just anomalous asteroids like Oumuamua. 3I Atlas distinguishes itself from both predecessors through its combination of characteristics: exceptional mass, non-gravitational acceleration without obvious corresponding outgassing, color variations, unusual trajectory alignment with our solar system's ecliptic plane, and sheer size. Each individual anomaly might have a natural explanation, but the clustering of so many unusual features in one object is what has scientists debating its nature. The December deadline. The next few weeks are absolutely crucial for resolving some of these mysteries. On December 19th, 2025, 3I Atlas will reach its closest approach to Earth at approximately 1.8 astronomical units, which translates to about 170 million miles, or 270 million kilometers. While that's still quite distant, it represents our best viewing opportunity. Hundreds of ground-based telescopes, along with space-based observatories, including Hubble and the James Webb Space Telescope, have this date marked for intensive observation campaigns. This observing window represents a critical test. If 3I Atlas is behaving as a normal comet that shed 13% or more of its mass through outgassing, a substantial, easily detectable cloud of gas should surround it in December. The Webb telescope's spectroscopic capabilities can analyze the exact chemical composition of this gas, revealing the interior chemistry of the object beyond just surface contamination. If the expected gas cloud materializes with appropriate composition and mass, the mystery largely resolves itself as an unusual but natural comet. However, if no substantial gas cloud appears, or if the cloud is significantly smaller than calculations predict, scientists face a genuine puzzle. The non-gravitational acceleration would require an alternative explanation beyond standard cometary processes. As Loeb stated in his analysis, if we don't observe the dense gas cloud in December, then cometary evaporation is not the explanation of its non-gravitational acceleration. The skeptics weigh in. It's essential to present the counter-argument because many mainstream astronomers strongly disagree with exotic interpretations. One expert quoted in news coverage stated that extensive peer-reviewed analysis from astronomers worldwide shows 3I Atlas remains consistent with having a natural origin. The scientific consensus view holds that its properties to date fit an icy planetesimal that formed around another star and was later gravitationally scattered from its home planetary system to traverse the galaxy until encountering our sun's gravitational influence. The skeptical position argues that apparent anomalies can be explained through incomplete data or the unique properties of interstellar comets. These objects have potentially been exposed to cosmic ray bombardment for billions of years, possibly altering their surface chemistry in ways we don't fully understand. The absence of a clearly visible tail might reflect observational timing, instrumental sensitivity limitations, or unusual ice composition, causing sublimation patterns we haven't previously encountered. Critics of the artificial hypothesis emphasize that extraordinary claims demand extraordinary evidence. Suggesting an object might be alien technology represents about the most extraordinary claim possible in astronomy, requiring irrefutable proof before serious consideration. Currently, the evidence consists of measurements that don't perfectly match existing models, but modeling imperfections don't constitute proof of artificial origins. As one researcher noted, scientific truth emerges from attention to data, not from popularity contests or jumping to dramatic conclusions. Here's what makes this situation genuinely exciting. This is science unfolding in real time before our eyes. Regardless of whether 3I Atlas proves to be an unusual comet or something unprecedented, we're learning the Vera C. Rubin Observatory in Chile should detect dozens more interstellar objects over the coming decade, and each one will give us more data points. Traditional SETI focuses on radio signals, but what if advanced civilizations deploy physical probes through the galaxy? Scientists are actively debating interpretations, publishing papers, and making testable predictions. Within weeks, the December observations will provide information that could fundamentally shift our understanding. As Loeb emphasizes, scientific truth emerges from attention to data, not authority or popularity. This isn't merely academic exercise. This is humanity collectively attempting to understand a visitor from another star system using our best available tools and minds. Subscribe right now because we're covering more stories from space. Hit that like button, drop a comment with your theory, and I'll see you in the next video. Keep looking up.